Hello everyone, welcome to Data Structures class. In this video, we will introduce Heap, which is a specialized tree-based nonlinear data structure. Heap structure is a tree-based structure, which organizes data in a way that satisfies heap property as a complete tree. Heap property such as max heap and mini heap makes a heap tree partially ordered. For examples, in a max heap structure, the root node always holds the maximum value in the tree. Contrarily, in a mini heap structure, the root node always holds the minimum value in the tree. Owing to the heap property, heap structure is used to implement the priority queue by considering the priority level as the key of a node. This is an example of max heap. The heap property of a max heap is that each parent node is always greater than or equal to its child nodes. As you can see on the right of the screen, the symbol P represents a parent node, and symbols C1 and C2 represent child nodes. The property of the max heap is that the key of P is always greater than or equal to that of its child nodes. For instance, as you can see, the key stored in the root node is 9, which is greater than or equal to that of its left child node, 8, and the right child node, 7. This heap property applies to the entire tree. This is an example of mini heap. The heap property of a mini heap is that each parent node is always less than or equal to its child nodes. As you can see on the right of the screen, the symbol P represents a parent node, and symbols C1 and C2 represent child nodes. The property of the mini heap is that the key of P is always less than or equal to that of its child nodes. For instance, as you can see, the key stored in the root node is 0, which is less than or equal to that of its left child node, 1, and the right child node, 2. The heap property applies to the entire tree. In a heap structure, one of the essential operations is to maintain the heap property. The term heapify is a tree reordering process based on heap property. When adding a new node into the heap, we append the new node to the end of the heap, which is the first empty slot at the bottom level. Given a heap tree as shown on the screen, as you can see, the first empty slot at the bottom level is on the right of level 3. Assume we want to insert a node with value 7 in this example. We add a new node with value 7 to the first empty slot as the right child node of inner node with value 3. As you can observe that the root node holds the largest value in the heap tree, which indicates that this is a max heap. The heap property of a max heap is that each parent node is always greater than or equal to its child nodes. As highlighted in red rectangle, insertion the new node with the value 7 violates the heap property of the maxima heap. For this reason, we swap node 7 with its parent node 3, so that nodes in the red rectangle satisfy the heap property. Once new node is reordered, we need to check whether the heap property holds. Again, we check the nodes in the red rectangle. As you can see, swapping the node 7 to the new position still violates the heap property of the max heap. For this reason, we swap node 7 with its parent node 6, so that nodes in the red rectangle satisfy the heap property. To this end, the new node with the largest value 7 has reached the root node in the heap tree. Thus, we can stop the heapify process. When removing from the heap, the root node is always removed. As highlighted in the red rectangle, after removing the root node, the heap structure is no longer maintained. Therefore, to maintain the heap structure, we move the last leaf node, which is the node with the value 1, to the root. As you can see, the root node becomes 1, which violates the heap property of the max heap. For this reason, we need to promote the largest child nodes to the parent node. In this case, the right child node is 6 and the left child node is 5. Thus, we promote the node 6 to the root node by swapping root node with the right child node. After swapping the root node 1 and the right child node 6, the heap property is satisfied as shown in the red rectangle. Swapping the right child node with the parent node has impact on the right subtree as shown in the red rectangle. Therefore, we need to check whether the subtree still maintains the heap property. As you can see, in the subtree, the parent node is 1 and the left child node is 3, which violates the heap property of the max heap. For this reason, we need to promote the largest child nodes to the parent node. After swapping, the parent node becomes 3 and the left child node becomes 1. The nodes in the subtree, as shown in the red rectangle, satisfy the heap property. To this end, the root node removal process in the heap tree is completed. Any questions?